Hello all, welcome to Code Hub. Today let us solve the Leetcode's daily challenge, and the problem is the longest increasing subsequence. Given an integer array nums, return the length of the longest strictly increasing subsequence. A subsequence is a sequence that can be derived from an array by deleting some or no elements without changing the order of the remaining elements. For example, the given array is 3627. No, so the 3627 is a subsequence of the array 0316227. As but this is a subsequence, but you cannot say this is an increasing subsequence. So we have to determine what are the increasing subsequence. So what is the length of the longest increasing subsequence? So we can take this array itself. This array. This is the array. We have to find the longest increasing subsequence. For this, what we have to do is the brute force approach was we can go for all the subsequence in the array, and we can find the longest increasing subsequence of that for each subsequence. For each subsequence, we will find the longest increasing subsequence, and we will store it in our maximum result, and finally we will return that. But this will be very exponential, and it will be very exponential, and it is not feasible. So we have to reduce our time complexity. So but our brute force solution is nothing but we are going to generate all the possible subsequences. That is 10 is a subsequence, just 10, 9 is a subsequence, then we can leave 10, then we can leave 9, and we can say 2 is a subsequence, and then we can say we can take the 5 as a subsequence in that array. So what does it mean is, it is meaning that we can take all possible combinations. There are n factorial ways to choose subsequence from this particular array. So we will so we what we can do is we can think of some recursive way that is going to give the longest increasing subsequence by serving through all the possible ways. So first what we can do is we can represent this particular array as indices I, and for generating the subsequence, what is the thought process that we can do is, for generating a subsequence we can make use of a technique called pick and not pick technique. Pick and not pick technique, where we will pick this 10, we will pick this element 10, and then we will go for the next recursive call. Or else we don't want to pick this 10, we can go for the next recursive call. This is nothing but the pick and not pick technique, and we will be using this pick and not pick technique for generating all the subsequences of this array. So we will search through all possible combinations, and finally we will just take the maximum of the result, longest increasing subsequence. But some logic we have to incorporate with this idea to get the longest increasing subsequence. So for particular index I, consider we are having at this we are at this index I, that is it is at the element 5. So how we can say this is going to form a longest increasing subsequence? So we want to have some previous element which is lesser than 5, so that we can include this element 5, or else we cannot include this element. So what I'm saying is, if I know some previous element or that previous index, the element at that previous index is smaller than this element, then I can pick this current element. Or else I cannot pick this current element. If I have picked 9 in my previous index, then I cannot pick this 5 at this current position, because 5 is lesser than 9. If I have picked previously 2, then what I can say is I can pick this 5, since 5 is greater than 2. So what I observe is we need some previous element or previous index such that the element with then in the previous index is smaller than the current element. So previous index is needed and the I is needed. So we have a previous index and an I. So we have two indices. So we are having this array and we are going to generate all the possible subsequences. While generating all the possible subsequences, we are also making sure that while generating this subsequence, it is increasing because we need the longest increasing subsequence. So we have to maintain this condition whether the subsequence is increasing or not increasing. So for that condition to be maintained only, we are using this previous index to store which element has been picked previously. That will say whether I can say that I can take this current element or not. So what I will be doing is if my previous if I will write just a recurrence relation, then I will go for coding. If my nums of my previous index is lesser than my nums of my current index then what I can say is I can pick this element or not pick this element. I can either pick this element or not pick this element. So that is what I can do here. So what I will say is I will take option 1 as let's say the function to be increasing subsequence. So I'm picking this element. Currently now I'm picking this element. That's what I'm saying. So if I pick this element, the current index will be becoming the previous index for the next iteration. So my current index becomes my previous index for my next iteration. And I will be going to my current index plus 1. So consider this is the previous index position. Let us say this is my option 2 and we are going to make all the elements position to be first position. That is either the subsequence can start from this 10, either the subsequence can start from 3 and go like 3 7 then 101 or 3 7 18. So for that what I can say is option 1 to be increasing subsequence of nums previous index stays the same and current index plus 1. So if this nums of previous index is less than nums of current index, then it is nothing but previous 1 plus. So like this I can say. So this is after this what I can say is I can return my maximum of this option 1 comma option 2. So this will be my recurrence relation, but we have to make sure that whenever we are choosing first element, we don't have the previous element for that first element. For this, if we are choosing this 10 as the starting point for any subsequence, what will be the previous element for this 10? There is no previous element. So we can say that previous index to be minus 1 initially. So if my previous index is equal to minus 1 or my nums of previous index is less than nums of current index, then my now my current index becomes my previous index for my next iteration and my current index will be incremented by 1 position. And since we are including the current element, we are adding 1 to this since then now my subsequence length is added by 1. So we are adding this 1 to this function call. And finally we are returning the maximum of this function. Let us copy this recurrence relation and just just do it. Actually this is the not pick case and this is the pick case. So let us code so that it will be more clear. So we will first return my increasing Subsequence. This is my function nums, and my initially the previous index is -1, and I will start from the current index 0. So I will have define a function private, inside which this is going to return me an integer variable, integer type, return an answer of integer type, and this is the function name is increasing subsequence vector int ampersand nums, and int previous index int current index. So whenever I come inside this loop, I'm just pasting this recurrence relation. Instead of saying this as int option 1, we can say it as int not pick. We are not picking this case, and this is nothing but we are picking this case, we are picking this position pick. And finally what we have to do is, initially my int pick position will be 0, and after doing this we are finally returning the maximum of pick and not pick case, and this is what we are doing here. So what will be my base condition here? The base condition is nothing but if my current index is going to reach my end of the array. If my current index is going to reach my end of the size of the array, then I can just return 0. Let us run our code and see whether we are getting the correct input, correct output for this problem. We got the correct output for this example test cases. Let us see. Yeah, we are getting the test cases accepted, but this is really exponential in nature, because we are each and every index we are picking this and not picking this. There are two positions, there are two cases, two possibilities, so the time complexity will be 2 powers n. This is exponential, so we have to optimize this. So since this is a recursive solution, we can just memorize it to, since we are having overlapping subproblems, we will be solving the problems again and again. Instead of doing that, we can just store it in some table, so that whenever the answer is pre-computed, we will make use of that pre-computed value. So what we can do is we can just memorize this solution. So to memorize the solution, we have to see what are the changing parameters. The parameters that are changing here is one. There are two parameters changing: previous index and current index. So since there are two parameters, we have to declare a 2D array vector of vector int dp of size n. Of size n, and vector int of size n, and initially I will initialize with -1 initially, and I will pass this dp array to my function as well with reference dp, and here as well I will be passing this dp, and here as well I will be passing the dp, and we have to memorize the solution. So dp of my previous index and my current index is memorized, now memorized, and we have to check for if it is pre-computed. If my dp of previous index current index is not equal to -1, then I will just return dp of previous index current index. If this is already found, then we can just return it. So anyways, if since the previous index is -1, we cannot access dp of -1. So what we can do here is we can store it in the we can have a size of n plus 1 with one extra size, and we can just store previous index plus 1, the dp of previous index plus 1, and here also dp of previous index plus 1, so that it will not make a conflict, since previous index is not minus 1 plus 1 becomes 0, so it will not be a conflict there. So now let us run our code and see whether it is running or not. Let us see. Oh sorry, maybe I have to pass dp here. I have passed minus 1. Yeah, after memorization also it is accepting. So let us try to submit our code and see whether it is getting submitted or not. Superb, it got submitted. So the time complexity for this solution will be order of n into n, since we are going and surfing through all possible subsequences, and the space complexity here will be order of n square as well. And I will say another possible solution here. How we can do is, for each particular index, let us calculate the maximum subsequence of length. How we can calculate is, if we are having this array, one minute. Okay, if we are having this array, initially we can say that each and every element forms the longest increasing subsequence of itself. That is, for each and every element it is 1, right? For each and every element is a longest increasing subsequence, so we can say it as 1. And for this 10, this is the longest increasing subsequence. For this 9, we can run a for loop from 0 till this 9 and see whether whether the current element is smaller than this element. If it is so, what we can say is, if 1 plus this dp of I is greater than this dp of j, then we can replace this dp of j with that incremental value. That is, since 10 is greater than 9, this 10 and 9 does not form a longest increasing subsequence. So what we can say is, we don't want to increment anything, so we can go for next iteration and let us go for 2, then it will be more clear. So since 10 is greater than 2, it will not form a longest increasing subsequence, and 9 is greater than 2, it is not form a longest increasing subsequence. Let us go for 5. In this case, 10 is greater than 9, so this is not going to form a longest increasing subsequence. 9 also will not form a longest increasing subsequence. But you can see that 2 is lesser than 5, so 2 and 5 can form a longest increasing subsequence. So what we can say is, if this is considered as dp of I and this is considered as dp of j, then 1 plus dp of I, 1 plus dp of I is 1. So 1 plus 1 is 2. Since 2 is greater than this 1, we can replace this 1 with 2. So this 2 indicates that till 5 there is a longest increasing subsequence of length 2, which is 2 and 5. Similarly, we can go for 3 and we can run a for loop from 0 till j and check whether there is some smaller element. 2 is smaller than 3. So 1 plus 1, which is 2, 2 is greater than 1. Yeah, it is greater. So we can replace this 1 with 2. Since 5 is greater than 3, we will not do anything. And we can come to 7. For 7, what will be the, we will be running a for loop from 0 to 7. Here 10 is greater than 7, 9 is greater than 7, 2 is lesser than 7. So 1 plus 1, which is 2, greater than 1. So we will replace it with 2. And similarly 2 is done. Now we will go for 5. Since 5 is lesser than 7, so since 5 is lesser than 7, there may be an increasing subsequence. So we will check to the 1 plus the dp of I. dp of I is 2. So 1 plus 2, which is 3. 3 is greater than 2. So we will replace this 2 with 3. and we will check 3 is lesser than 7 and 1 plus 2 is 3. 3 is greater than 3, but it is not going to update since already we have a 3 in this position. So what does this indicate is till 7, from the index 0 till this element 7, there is a longest increasing subsequence of length 3, which is either 2 5 7 or 2 3 7 or 5, that's it, 2 5 7 or 2 3 7. So the length, it is of length 3. So like this, if we fill this dp array and if we take the maximum of that element, if we take the maximum of this dp array, then we can find the longest increasing subsequence of length. So while doing this, the time complexity will be order of n square and the space complexity will be order of n only. Here we have reduced the space complexity, it is order of n square space complexity. Here we have reduced it to order of n. So let us do this approach and see. This is an iterative approach. So we will declare a size dp of n and initialize it with 1. Since already the elements, already all the elements at that position is an increasing subsequence of length 1. So and finally we will have a longest max length. With this initialized, we can have a default value as 1 and we will finally return this max length. So what we are doing is we are running a for loop from int I equal to 0, I less than n, I plus plus, and each and every time when we comes inside the for loop, we will be running another for loop from int j equal to 0, j less than I, from till j less than I, j plus plus. We will be checking two conditions. If my nums of I, nums of nums of j is lesser than nums of I, then this can form a longest increasing subsequence. And we have another condition. If my 1 plus dp of j is going to be greater than my dp of I, current position I, then what we will do is we will update this dp of I to be 1 plus dp of j. And whenever we update this, we will update our max length also to be maximum of max length comma dp of I, and finally we are returning our max length. So let us run our code. This is more simpler than this previous approach, but the previous approach is more intuitive way. So but you guys want to know this approach as well. Let us submit this code as well. Here the time complexity will be order of n square and the space complexity will be order of n. And hope you like this video, and I have discussed with you the recursive approach, then the memoization approach, then I have not done the tabulation form of that memoization, but I have done another method with order of n square time and order of n space. Hope you like this video. Let me know in the comments, and let us see in tomorrow's Leetcode daily challenge. Until then, bye.